Welcome student, how are you? I am dear Majhi, teach physics for NEET, mains and advanced. I have uploaded many videos relating to free body diagram. You can watch this video given in the link in my description box. I hope this video will be beneficial for you because level of FBD is starting from the foundation level to the JE advanced level. Now today I will be discussing about the spring. Look at this. This is the spring. Okay, and about the spring and its force constant and what will be the force constant after its cutting, the equivalent force constant in series combination, equivalent force constant in parallel combination, and suppose this is a ring and it is connected by a spring. The spring is stretched something and we have to calculate the tangential acceleration and normal reaction between the ring and now look at this. We have to calculate acceleration when this string is cut. Now here also calculate the acceleration when this string is cut. Okay, this string cut, and we have to calculate acceleration A, B and C when this string is cut and when this spring is cut and this string is cut. Okay. Now first of all, spring. According to Robert Hooke, the force acting on a spring is directly proportional to its displacement. Suppose F force acting on it. If F force acting on it, so the elongation, suppose elongation be x. According to Robert Hooke, the force acting on a spring is directly proportional to the balance force acting on it. So look at this here, F proportionate x. Therefore, F equal to kx. When the spring elongates, spring try to neutralize the force acting on it. So restoring force acting upward direction in the spring. Okay. Now here k equal to, look at this, F by x. Now here k equal to F by x is called force constant. Now if x equals to 1, then k equal to F. So the force constant is the balanced force acting on a spring to produce unit elongation. Its unit is Newton per meter and dimension m L T minus 2 divided by L. So its dimension is m2 minus 2. The dimension just as the dimension of surface tension or surface energy. Now, what will be the force constant if the spring is cut into two equal parts? If the spring is cut into two equal parts, look at this, the elongation of each part due to application of force F is x by 2. So, force constant K1 equal to K2 equal to force by elongation unit. So, this is the 2F by x. So, this is the 2k. Therefore, if a spring is cut into two equal parts, the force constant of each part is 2k. If the spring is cut into three equal parts, then force constant in each part is 3k. If the spring is cut in the ratio m is to n, then force constant of first part k1 equal to m plus n into k divided by n. And force constant of second part is m plus n by n into k. Okay, understand? If this discussion is helpful for you, please like, comment and share the video. If you are new, please subscribe my channel. This channel gives a tremendous amount of lecture based for NEET, mains and advanced. And I assure you, this channel is sufficient to prepare for NEET, mains and advanced. If you have any queries relating to physics, I solve this query as soon as possible. The series combination, look at this, this is the series combination of spring. Force constant of this spring is K1 and this spring is K2. Okay. Now look at this, if F balance force, look at this, if F balance force acting on it. Now force on each spring be also, suppose elongation of this spring is x1 and elongation of this spring is x2. So look at this, the total elongation becomes x1 plus x2. So this is the x1 plus x2. Okay. Now look at this. Here balance force acting on it is F. So look at this. x2 equals to becomes F by k2. And here balance force acting on it is F1. So x1 equals to F by k1. And look at this, the resultant force acting F for the elongation x. So this becomes F by k, where k is the equivalent force constant of the spring. Understand? So look at this becomes 1 by k equals to 1 by k1 plus 1 by k2. Okay? This is the parallel combination of spring. Look at this. In parallel combination of spring, elongation of each spring becomes same. Look at this. A force divided between the two springs k1 and k2. Suppose force acting on the spring having force constant k1 is F1 and other spring is F2. So F becomes, look at this, F1 plus F2. Okay, F1 plus F2. Now look at this here. F1 equal to, look at this, k1 into x plus F2 equals to k2 into x. Okay. Now the total force acting on the equivalent spring is F. So this F equals to k into x. Therefore k equals to k1 plus k2. So equivalent force constant in parallel combination is equal to sum of the force constant of each spring. Okay, understand? The natural length of the spring is 3r by 4. The spring is stretched such a way that the spring is stretched in such a way that it makes an angle 60 degree with the vertical. We have to calculate the normal force acting on it and tangential axis of the ring. Okay, tangential axis of the ring. Now we have to draw the free body diagram on it. Look at this 60 degree, look at this is the R and this also R, this also 60 degree, so this also 60 degree. So final length, look at this, final length of the spring, final length is equal to R. Initial length, look at this, 3r by 4. So elongation x equals to, look at this, r minus 3r by 4. So look at this is the r by 4. Therefore spring force acting, look at this, spring force acting here this direction and this spring force equals to k r by 4. Okay. Now point mg acting vertically downward. So this is the mg. Okay. Now look at this. So total angle, this angle, look at this is the vertical, this is the vertical. So this angle is 60 degree. Now we have to resolve the component of force mg along the tangent of the circular track and normal to the circular track, and the component of spring force along the circular track and normal to the circular track. Look at this. This angle is 60 degree. This tangent is, this angle is 90 degree. Okay, this angle is 90 degree. So this angle is 30 degree. Okay. So component of spring force, look at this is the kr by 4. This becomes kr by 4. This is the cos 30 degree. Okay. Look at this total angle 60 degree. So this also 30 degree. So component of mg along the tangential, this is the mg cos 30 degree, and component of mg along the normal to the track is equal to mg sin 30 degree, and component of spring force along this direction, this is the kr4 into sin 30 degree, and suppose this is the normal reaction. Okay. So look at this. Look at this, the forces along the tangent to the part. Look at this, the component of kr by 4 along this direction and component of mg cos 30 degree along this direction. So tangential acceleration becomes tangential force acting on the ring divided its mass. So tangential acceleration AD equal to, what is the tangential force? Look at this. This is the, look at this is the K, look at this is the KR cos 30 degree plus mg cos 30 degree, and this divided by m. Okay, now the force constant of the spring is mg by r. If the force constant of the spring is mg divided by r, so if we put the value, look at this is the mg by r into r by 4, this is the root 3 by 2 plus mg into root 3 by 2. Look at this, so this is the mg root 3 divided by now the force constant of the spring is, this is the mg by r. So look at this, so kr by 4, so kr by 4, this becomes mg by 4. So look at this, if we put the kr by 4, look at this, the force constant of the spring is mg by r. So kr by 4 is equal to mg by 4. Okay, now if we put the kr by 4 here, so we get, look at this is the mg by 4 into root 3 by 2 plus mg into root 3 by 2 divided by m. So this becomes, look at this, g into root 3 by 8 plus root 3 by 2. So this becomes 5 root 3 by 8 into g. So tangential axis of the ring is 5 root 3 by 8g. Okay, understood? Normal force acting n towards the center, kr by 4 towards the center, and mg sin 30 away from the center. So this force plus this force equal to this. Therefore n plus mg by 4 into half equal to mg by 8. Therefore n equal to, look at this, mg into half minus 1 by 8. So look at this is the mg into 3 by 8. So this becomes 3 mg by 8. Okay, understand? Hello student, this numerical is very easy, considering only these two angles. Look at this angle equal to this angle. Okay, and look at this is the tangent and this is the line joining center, makes an angle 90 degree. Okay, if this angle makes a 90 degree, this is the 60, this is the 60, so this angle obviously 30. Now total angle 60, this is the 30, so this is also 30. Now you have to just resolve the spring force kr by 4, that is the mg by 4 along the tangent and towards the center, and also we resolve mg along the tangent and away from the center. Okay, please share, like and comment the video. Now look at this problem. Look at this is the mass m, this is the mass m, and this is a string. What is the acceleration of this mass and this mass if spring is cut? We have to draw the free body diagram before cutting. Before cutting, suppose elongation of the spring be x. So look at this, the forces acting on B of mass m, mg downward and spring force kx vertically upward. So in equilibrium, upward force equal to downward force. So this is the kx equals to mg. And for A, look at this, kx, spring force kx downward, mg downward and T upward. So look at this, here T equal to kx plus mg. Okay, when string is cut, the balance force between the spring does not change instantly. Look at this. After cut, the freeway diagram for B, kx, mg. Upward force kx, downward force mg. Okay? Because the spring does not respond instantly when the cut. Spring takes some time to respond it. Okay, so at the time of cutting, the free body diagram for B, kx upward, mg downward. And for B, look at this, tension T0 because the spring is cut. And the force kx and mg in the downward direction. So look at this, the axis of A. Look at this, the resultant force kx plus mg minus 0 by m. Okay, understand? Now look at this is the kx. kx equals to mg plus mg by m. So this is the 2g. Understood? Now next for b. Look at this here, upward force mg, downward, so here upward force kx, downward force mg. So acceleration of AB equal to, look at this, mg minus kx by m. Look at this, kx equals to mg. Kx equals to mg. Look at this, kx equals to mg. So look at this is the mg minus mg by m. So this is to 0. Okay. So acceleration of A becomes 2g and acceleration of B becomes 0. Understood? Please like, share and comment the video. Okay. Look at this problem. Look at this, mass M is connected between the ceiling and the spring is connected between the mass M . Now, a spring is connected between ceiling and block A, and a string is connected between block A and block B. We have to calculate the acceleration when the string is cut. Now, we have to draw, first of all, we have to draw the free body diagram of A and B before cutting. Look at this. Look at the free body diagram here for A. Look at this. This is the spring force kx, tension of the string T downward and mg downward. And for B, look at this. This is the mg downward and tension T upward. Equilibrium, we get T equal to mg. And look at this. Kx equals to T plus mg. Understand? So this is the T plus mg. Okay. Now we draw again free body diagram when the spring is cut. Look at this. When the string is cut, the tension becomes 0. So look at this. Look at the free body diagram of A. Look at this. The spring force remain intact because the springs are lazy. So they takes time to respond it. Okay. So look at this. The spring force kx. Look at this. Kx equals T plus mg equal to mg plus mg equals to 2mg. So spring force 2mg acting vertically upward, mg downward and tension T0 because spring is cut. Because the string is cut. Now the force acting on B, look at this, mg and T becomes 0 because spring is up. So easy, you can calculate acceleration A and B easily. Now look at this, the free body diagram. Upward force 2mg, downward force mg. So acceleration A equal to, look at this, 2mg minus mg by m. So look at this, the g is upward direction. So acceleration of A in upward direction. Understood? Please share the video. Now next, here look at this, upward force 0, tension T0. Now here only force, this is the mg by m. So this is the g in the downward direction. Okay, understood? Please share the video. Now look at this. This is the spin of force constant K. This is the spin of force constant K, and this is a string. We have to calculate the acceleration of A, B, C and tension of the spring when upper spring is cut. Before cutting, we have to draw the free body diagram of A, B and C. Now look at this. Before cutting, the forces acting on C, the spring force Kx and weight mg. As it is balanced, so look at this, Kx equals to mg. Understood? Now for B, look at this. Here tension of the string upward direction, spring force downward direction and weight mg and weight of B in downward direction. So look at this, T equals to mg plus Kx. Now Kx equals to mg. So T becomes, look at this, mg plus mg. So this is the 2mg. Understood? Now next, look at this. Here spring force Kx dash, tension downward, mg downward. So look at this, Kx dash equals to T plus mg. So look at this, 2 mg plus mg. So this is the 3 mg. Okay? So look at this. In equilibrium, Kx dash equals to 3 mg, tension equal to 2 mg, and Kx equals to mg. Understood? Now, when the spring is cut, look at this. When the spring is cut, Kx dash equal to 0. Understood? When spring is cut, Kx dash equals to 0. Now, we have to draw the free body diagram. Look at this. When upper spring is cut, lower spring does not respond quickly. Okay? Now, look at this. The acceleration of C, look at this. The acceleration of C, look at this, the resultant force by mass. So look at the resultant force mg minus kx by m. This is the acceleration of C. Now look at this, kx equals to mg. So its acceleration AC equals to 0. Understood? We have to calculate the resultant forces acting on A and B. Now look at this, for A and B, look at this, for A and B, look at this, the forces acting on it, 2 mg plus kx. Okay? So what will be its acceleration? Look at this, A equal to AB, this equals to 2 mg plus kx. Look at this, 2 mg plus kx divided by mass twice m. So look at this, kx equals to mg. Therefore, this is the 3 mg. This is the 3 mg by 2m. So this is the 3g by 2. So this is the 15 meter per second square. Now, what is the tension of the string? To calculate the tension, look at this A. Look at A, this is the tension T. This is the weight mg. Okay? And moving downward direction by 3g by 2. Okay? So look at this. T plus mg, this equal to m into 3g by 2. Look at this. Net force equal to mass into acceleration. So look at this, T equals to, look at this, 3 mg by 2 minus mg. So this is the mg by 2. So tension of the string, is equal to mg by 2. Okay? So look at this, before cutting, the free body diagram of A, B and C is same as earlier. Now what happens when the spring is cut? Okay? Now look at this. When the spring is cut, what is the free body diagram? Now look at this. The free body diagram when the string is cut. When the spring is cut, the springs do not respond quickly due to the laziness of spring. Now look at this. The free body diagram. This is the kx and this is the mg. Kx is to mg. So no resultant force here. So what is the acceleration? Resultant force by mass. So resultant force 0. So acceleration AC equals to 0. Okay. Now what is the forces acting on B? Look at this, tension T0 and downward force mg and kx. Then this direction. So what is the resultant force? Downward direction mg, upward direction 0. So resultant force, what is the resultant force? 2 mg minus 0. What is the acceleration? Resultant force by mass. So acceleration equals to 2 mg by m. So this equals to AB equals to this is the 2g. Understood? Now, what is the forces acting on it? Look at this. This is the 3 mg. And this is the mg because T0. Here upward force 3 mg. Downward force mg, T0. What is the resultant force? Upward 3 mg, downward mg. So resultant force is 3 mg minus mg, 2 mg. So what is the acceleration? Look at this, 3 mg minus mg by m. So this is the acceleration of A and this is the 2g in upward direction and this acceleration 2g in downward direction and this acceleration is 0. Understood? Please share the video. What will be the acceleration of ABC when lower spring is cut? So look at this, the free body diagram of ABC is same as earlier. Now what is the free body diagram of, look at this, what is the free body diagram of C? Look at this, this spring force is 0. Look at this spring force is 0. Okay? And tension remains in intact. Tension remains in intact. Okay? Understood? Now, what is the forces acting on it? Look at this. Look at this. When this spring is cut, this spring force remains 0. So, what is the forces acting on C? Look at this. What is the forces acting on C? Only mg. So, what is the acceleration of it? Look at this. AC equal to mg by m. So, this is the g in the downward direction. Understood? When the spring is cut, the spring force kx becomes 0. But kx remains same because this spring does not respond quickly as it is cut. The forces acting on combination of A and B, 3 mg upward direction and 2 mg downward direction. So its acceleration becomes, look at this, 3 mg minus 2 mg by mass 2 m. So this is the g by 2. So acceleration is the g by 2. What is the tension? Look at this. What is the tension of this string? Look at this. Due to this tension, the B mass moves in upward direction with acceleration g. So look at this. The resultant force T upward, mg downward, and acceleration upwards. This is the g by 2. Okay. Now for B, T minus mg. This is the m into g by 2. So T equal to 3 mg by 2. The tension of the string becomes 3 mg by 2. I hope this video will be beneficial for you. Please like, share and comment the video. And if you are new, don't forget to subscribe my channel for further update.